Air and combustion. Air sustains life on Earth. Living organisms need air for respiration. Plants need air for photosynthesis. Air is required for combustion of fuels to give energy. Air is a mixture of gases such as oxygen, nitrogen, carbon, oxide and water vapor. About 78.1% of air is nitrogen, 20.9% oxygen, 0.03% carbon oxide. Noble gases comprise about 0.97%. Other components include water vapor and dust whose composition vary from place to place. As already mentioned, air is required for combustion of fuels to give energy. In order to learn the percentage amount of air that supports combustion, we shall observe a few experiments. In this experiment, dilute sodium hydroxide is put in a trough. A small candle is placed on a cork and floated on the solution as shown. It is then covered with a glass jar. The level of the solution in the glass jar is measured. The height of the air column is measured and recorded. The jar is then removed and the candle is lit. The burning candle is gently covered with the glass jar. After the candle has gone off, the apparatus are left to cool at room temperature. The final level of the solution is marked. The height of the air column is measured again and recorded. The glass jar is removed and the change in height is recorded. The candle burns for a while, then it goes off. As the candle burns, it uses up the active part of the air in the fixed amount of air enclosed in the gas jar. This leaves a partial vacuum in the jar. Greater atmospheric pressure acting on the surface of the sodium hydroxide forces the solution up into the jar to occupy the vacuum left. In this experiment, the height of air column before burning was 15 centimeters. The height of air column after burning was 12 centimeters. Therefore, the height of air used during burning was 3 centimeters. The percentage of air by volume used up is calculated as height of air used, 3 centimeters, divided by the initial height of air, 15 centimeters, multiplied by 100. Combustion or burning is a process in which a substance combines with oxygen with the production of heat. The part of air that supports combustion is active air. The active part is oxygen, which forms about 20% of dry air by volume. The part of air that remains in the gas jar does not support combustion. The component of the air that is inactive is mainly nitrogen. The experimental result is not the same as the theoretical value of the percentage of oxygen in air by volume. This is due to experimental error, which may result from several reasons. For instance, the sodium hydroxide solution may not absorb all the carbon, oxide gas. The candle may go off before all the oxygen is used up due to the buildup of carbon, oxide levels. Dilute sodium hydroxide is preferably used instead of water, to absorb carbon oxide that was initially in the gas jar and that which is produced during combustion. Heating causes expansion of gases, therefore the apparatus should be allowed to cool before the final reading is taken. Experiment. What proportion of air is used up when copper is heated in a fixed volume of air? Let's observe this experiment to learn what proportion of air is used up when copper is heated in a fixed volume of air. In this experiment, copper turnings are packed in a long hard glass tube as shown. The tube is connected with two glass syringes, with one syringe containing a specific volume of air while the other is empty. The copper turnings are heated until they are red hot. The air from syringe A is slowly passed through the hot turnings to syringe B and back. The process is repeated while heating the copper turnings until the new volume of air in syringe A is constant. The glass tube is allowed to cool and the volume of the gas in the syringe is recorded. Copper is a red-brown metal. When it is heated in air, it turns black. This is because it combines with oxygen to form black copper 2 oxide. The word equation for the reaction is copper, a red-brown solid, plus oxygen, a colorless gas, forms copper 2 oxide, a black solid. The following are the sample results for the experiment. The volume of air in syringe A before heating was 7.5 cubic centimeters. The volume of air syringe A after heating was 6.0 cubic centimeters. The volume of air used up during heating was 1.5 cubic centimeters. Therefore, to calculate the proportion of air used up when copper is heated in a fixed volume of air, this formula is used. Volume used during heating, divided by the original volume of air, multiplied by 100. This indicates that about 20% by volume of air is used during combustion, and the 80% of air left does not react with heated copper. In this experiment, the glass wool is used to stop the copper turnings from being sucked into the syringes. The air is passed repeatedly over heated copper to ensure that all oxygen in the syringes and tube is used up. The air is passed slowly to allow enough time of contact between the reactants. The gas left in the syringe does not react with copper. It is mainly nitrogen. The possible sources of error in this experiment include: the air initially present in the tube is not accounted for. There is possible leakage of air. Not all the oxygen may have been used up. Experiment. What percentage of air is used up when iron filings rust? Let us observe this experiment to learn what percentage of air is used when iron filings rust. In this experiment, a measuring cylinder is made wet and sprinkled with iron filings on the wet surface. The measuring cylinder is inverted in a trough of water. The volume of air in the column is noted. The setup is left for 48 hours. The measuring cylinder is made wet to ensure that the iron filings stick onto the wet surface. When iron filings are left for 48 hours in the measuring cylinder, a brown coating is formed on the fillings. The brown coating is rust. Rust is a compound of iron and oxygen. During rusting, oxygen is used and therefore water rises up in the measuring cylinder to replace the volume of air used during rusting. About 20% of air by volume is used up during rusting. Experiment. What percentage of air is used up when white phosphorus smolders? Let us observe this experiment to learn the percentage of air that used up when white phosphorus smolders. In this experiment, an empty cylinder is inverted in a trough of water. The volume of air in the column is recorded. A small piece of white phosphorus is cut underwater. The piece of white phosphorus is attached to the end of a piece of copper wire. The setup is left overnight and the volume of air in the column recorded. Yellow and white phosphorus smolder in air. This is because phosphorus reacts spontaneously with oxygen to form a mixture of oxides. This explains why phosphorus is stored underwater, as it does not react with water. The reaction can be represented by the following word equations. Phosphorus plus oxygen produces phosphorus 3 oxide. Phosphorus plus oxygen produces phosphorus 5 oxide. After 24 hours, the water level inside the measuring cylinder will have risen to occupy the volume of oxygen used up. The difference in volume can be used to calculate the percentage of oxygen by volume in air. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.